Hi, this is Jack from Maths Forge, and in today's lesson we're going to be doing circle theorems. So for the one-star examples, there are 3 different circle theorems that you need to know. Here's the first one. Here we're being asked to find x. Now this circle theorem can be described by the following. Angles in the same segment are equal. And how you can identify this circle theorem is that it looks like a bow tie, or it looks like a butterfly. And this center point here is the center of the circle. So there's no necessary connection with the center of the circle in this case. It's just 2 triangles intertwined with each other, and they have 4 points touching the circumference of the circle. So now that we know that angles in the same segment are equal, we can say that x is equal to 47 degrees. Now, these 2 angles are equal to each other, but they are not necessarily equal to these 2 angles here. However, these 2 angles here are also equal to each other. And that's what we mean by angles in the same segment are equal. These 2 angles here are in the same segment. And if we check our answer, there it is. Our second circle theorem is the following. It's a triangle within a circle. All 3 corners of the triangle are touching the circumference of the circle, and the longest side of the triangle is actually the diameter of the circle. So it's the length that goes through the middle section of the circle, and it goes through the center of the circle as well. This circle theorem can be described by the following. The angle subtended at the circumference by a semicircle is 90 degrees. So if you have a triangle within a circle and all 3 corners of the triangle are touching the circumference of the circle, and one of the sides of the triangle is the diameter of the circle, then this angle over here is 90 degrees. Now we don't know what these 2 angles are, but we know that this angle here facing the center of the circle is 90 degrees. So I'm going to go ahead and say x is equal to 90 degrees. And if we check our answer, there it is. Now for our third circle theorem, here we have a quadrilateral, so a 4-sided shape within the circle. And if you notice, all 4 corners of this quadrilateral are touching the circumference of the circle. Now this circle theorem can be described by the following. Opposite angles in a cyclic quadrilateral add to give 180 degrees. So if you're dealing with this, the opposite angles in this quadrilateral add to give you 180 degrees. So this x plus this 85 should give us 180 degrees, and these 2 opposite angles here, whatever they are, should also add to give you 180 degrees. But since they're asking us to find x, I can go ahead and structure the following equation. X plus its opposite angle of 85 degrees gives us 180 degrees. And now just rearranging for x, so if I cancel out this plus 85 by subtracting 85 from both sides, we end up with x is equal to 95 degrees. Now it's very important for you to commit these descriptions to memory. Most of the time in the exam, if you're being asked to find an angle using circle theorems, they'll usually ask you for an explanation. So in this case, if they asked us for an explanation, we could say that angle x is equal to 95 degrees because, and then just state the circle theorem. Opposite angles in a cyclic quadrilateral add to give 180 degrees. And if we check our answer, there it is. Now we'll do a 2-star example. This circle theorem here kind of looks like an arrowhead, but it doesn't always look like this. The important thing to remember is the following. It's a quadrilateral, a 4-sided shape, and 2 of the sides are fixed at the center of the circle. So the description for this circle theorem is as follows. The angle at the center is twice the angle at the circumference. So here's the angle at the center here, x, and this angle here is double the angle at the circumference, which is this angle facing it, that's 62 degrees. So we can say that x is going to equal 62 times 2, and therefore x is equal to 124 degrees. And if we check our answer, there it is. Now this can be a tricky circle theorem, so I'm going to show you another example of this where it does not look like an arrowhead. Here's an example where the angle at the center is twice the angle at the circumference, and it does not look like an arrowhead. However, it does have 4 sides, so it is a quadrilateral, and 2 of the sides are fixed towards the center of the circle. And you have to be very careful with this one here, because the angle that's double 104 degrees, the angle at the center, is the angle on the outer side of these 2 sides here. So this x is not double 104 degrees. This shaded angle here is. So this angle here is double 104 degrees, which makes it 208 degrees. And the total angle around the point is 360 degrees. So we can find x by doing the following calculation. 360 degrees, which is the total angle around this point here, minus this 208 degrees. This will leave us with the remaining angle here, x. So 360 minus 208 gives us 152 degrees. And if we check our answer, there it is. So the explanation for this circle theorem would be the angle at the center is twice the angle at the circumference, and the total angle around a point is 360 degrees. So there are two explanations for you to get to the answer here. And I'll show you one more 2-star example of this arrowhead circle theorem that doesn't look like an arrowhead. So you can see here that we have 4 sides, so 1, 2, 3, and 4, and 2 of the sides are fixed towards the center, where the other corners are fixed on the circumference of the circle. So this is the circle theorem where the angle at the center is twice the angle at the circumference. But the pointed head here of the arrow, you can imagine it moving across the circumference of the circle and forming an arrowhead. But in this case, it's been warped out of position to look like this. So now we can conclude, because the angle at the center on the outside here is twice the angle at the circumference, x is equal to 36 multiplied by 2. And therefore x is equal to 72 degrees. And if we check our answer, there it is. Now for the 3-star examples, there are 3 circle theorems you need to be familiar with. The first one is a circle with a tangent to the circle. A tangent just means a straight line that touches the circle at one point of its circumference. Now something you should know about a tangent to any circle is that it forms a right angle with the radius of the circle. So this angle here, x, is going to be 90 degrees. And the description for this circle theorem is a tangent to a circle will meet the radius of the circle at 90 degrees. And if we check our answer, there it is. Now we will do our 6th circle theorem and the second example for the 3 stars. So in this circle theorem, you have a point outside of the circle and then 2 tangents coming out of this point. They'll touch the circumference of a circle at a single point. And the description for this circle theorem is as follows. Tangents from a point have equal length. So let's go ahead and find this angle here, x, using the information we have. From the previous circle theorem, we saw that tangents meet the radius of a circle at 90 degrees. So now that we know that these 2 lines here are tangents, we know that they are going to meet the radius of the circle here at 90 degrees. And so now we're dealing with a quadrilateral, which I'm just going to outline in red. And so to find the angle x, we should know that the total angle in a quadrilateral is 360 degrees. So using the information here, we know that 2 of the angles in this quadrilateral are 90 degrees. And the third one here, which they've given us, is 86 degrees. And finally, the 4th angle x should all add up to give us 360 degrees. Simplifying these 3 here, we get 266 degrees. Then we add x onto this, and this gives us 360. Subtracting both sides by 266 to get x on its own leaves us with x is equal to 94 degrees. And if we check our answer, there it is. Now for our 7th and final circle theorem, here we have a tangent to a circle, and we have a triangle within the circle where all the corners of the triangle are touching the circumference of a circle, and one of the corners is also touching the tangent. Now the description for this circle theorem is pretty short. It is known as the alternate segment theorem. And in the alternate segment theorem, the angle formed between the tangent and the triangle, so this angle here, is equal to the angle at the other end of the triangle, which is this 44 here. So for this example, we can say that x is equal to 44 degrees. And if we check our answer, there it is. Now the thing with circle theorems is the more you practice, the more likely you are to remember them, and the better you get at being able to answer more complicated questions. So definitely go ahead, commit the 7 circle theorems to memory, and practice as much as you can. And that's it for our lesson on circle theorems.